Okay, YouTube, in this video we're going to start talking a little bit about variable relationships. And so just to start this off here, I suppose frequently we look at a relationship between, it could be two or more quantities, but specifically in this video, say two quantities as an equation that we represent with two variables. And often what we do is we tend to use x and y, these two variables that are ubiquitous. You see them everywhere. So what we're going to look at here is what we call a solution to an equation in two variables. And so we say specifically that a solution point, okay, so this is something that we can graph, a solution point to an equation is some ordered pair. And specifically we're saying A and B, but we're saying that it is a solution if and only if it satisfies the equations when the substitutions x equals a and y equals b are made. So that is to say that if I were to put this into my equation, everywhere I see an x, put an a instead, and everywhere I see a y, I'd put a b instead. As long as I get a true statement, then we would say that that particular point happens to be a solution of that equation. It's a solution point. So specifically what we're going to be getting into are graphs, but we say that the graph of an equation really is just the set of all solution points to an equation. So a graph shows the solutions to its particular equation. So what we're going to look at specifically is checking to see whether or not an ordered pair would be a solution to an equation. So just by using substitution with the x and y values, what I want to do with this equation here, y equals 2 minus 3x, is determine whether or not any of these 3 points down here are solutions to the equation. So very, very simply, what we're going to do is we're just going to make some substitutions here. And everywhere I see a y, we'll replace it with this 2. And everywhere I see an x, we're going to go ahead and run a substitution there. It looks like in this case, our x value is 0. So evaluating both sides or simplifying both sides using order of operations, looks like we get 2 on the left, and on the right side, we'd have to do 3 times 0. First, we get 2 minus 0. So in other words, 2 is 2. But all this does is it really verifies that this right here is a solution point and would therefore be on the graph of this equation. Now, checking out the second point here, would this be a solution? Y equals 2 minus 3x. We're going to run a substitution again, and everywhere we see our y, we'll replace it with this positive 2 here. And everywhere we see an x, it looks like we have a positive 2 here as well. So looking at this, we would see that 2 on the left and 2 minus 6 on the right is what we get for our expressions. In this particular instance, we get 2 equals negative 4. So since this is a false statement here, we would say that this point is not a solution point. It's not a solution point. So checking out this last one here, let's go ahead and again run our substitutions here. We have y equals 2 minus 3x, where in this case we'll have our y value equals 2 minus 3x. And in this case, looks like our, let me switch back to my pen tool here. Looks like our y value here is negative 1. So we're going to substitute a negative 1 and our x value is 1. It looks like we get negative 1 equals 2 minus 3 times 1, or in other words, negative 1 is negative 1. So it did turn out that we had two solutions or solution points for this particular equation. Cheers.